Thanks for joining before we start. Today we're gonna have two sessions. The first one is SQL encryption by SQL encryption. We're gonna talk about always encrypted, and then on the second session we have Fabiano from Brazil. He's gonna talk about SQL Server 2019 for performance tuning improvements. We're gonna start in 2 minutes. Hello everyone. Welcome to Data Sessions. Uh, Today we're gonna have episode 3, the last episode for the month. Let me just quickly switch to my PowerPoint. Just a few housekeeping uh, slides before we start the session. So, Data Session is brought to you by Singapore SQL Pass. If you haven't joined us, you can find us on Facebook. You can also join the meetup group for the Microsoft Singapore community, user group community. You can find all the events for various user groups in Singapore at this page. So that's MSSGUG at Meetup. So the Azure group, the Office and data is in there, even the AI. So you can follow us there and find out about all about the events that are happening around Singapore. If you haven't subscribed to our YouTube channel, you can subscribe using this link. You can find all the past events and past episodes. For example, for data sessions, you can find them all you can find them all in YouTube. If you have any comments or suggestions about our meetup, you can email us directly. Those are the email address of your organizers. You can connect with us. If you have any questions about the group, about about Microsoft Data Platform Technology, you can reach out to us. And then before we start, tomorrow there's a meetup for the Azure user group. If you are interested in finding out about Azure Migrate, you can join the session tomorrow. You can find the event at Meetup. Sarah Lynn will be there to talk about Azure Migrate. And then a few reminders before we start the session. Keep yourself on mute so that it will be a pleasant experience for everyone. So during the session, kindly keep yourself on mute. If you need to ask any questions or if you need to say anything, you can use the raise hand icon, or you can put it into the chat. If you are joining us on the live stream, you can comment your question, and then our moderators will relay the question to our speakers. And later on, after the sessions, we do send out evaluation links. If it doesn't take more than 2 minutes, if you have the time, kindly provide some evaluation about the session and about the event so that we can improve our meetups. And you can also provide feedback to your speakers if you have any questions. That's the best way to directly send it to them. And then just a few reminders: the sessions will be recorded. So let me just start the recording. All right, so our first session for episode 4 is SQL Encryption 101, always encrypted. Full disclosure, we were supposed to have Dharmendra Kashari today for about talking about deployment, enterprise deployment, but for during the last minute, he has some work assignments, so he won't be able to join us today. So instead of that, we're gonna talk about always encrypted. If previously on our first episode, we talked about SQL encryption. So this is the part 2 of that talk. So yeah, so SQL encryption, always encrypted. We're gonna talk about always encrypted. Previously, we talked about encryption hierarchy, and then we take a deeper look at transparent data encryption, how it works, what the things that you need, and when do you use TDE. And then after that, we talked about cell level encryption, wherein you can encrypt column level data for your tables and data for the tables in your database. So after that, on the last slide, we talked about what's next. So the next thing that we're going to talk about is always encrypted. And then if we have time, we're going to talk about always encrypted secure enclave. I put an asterisk there. I'll talk about it later on why I put an asterisk on secure enclave. So we'll go into details later on. Let's first start. Before we start, I would like to introduce myself. There was a comment on the evaluation that I didn't introduce myself on all the sessions. So yeah, I'm Pio Balistoy. I'm a lead Microsoft Data Platform consultant for PTN. I'm a Microsoft Data Platform MVP. I'm also all those logos on the left side. I am one of your organizers for SQL Pass Singapore. I also administer the Philippine Data Platform Forum for the SQL Server user group community for Philippines. If you want to reach out to me, if you want to talk about data, you want to ask anything about SQL Server, you can reach out to me through all those channels. I've been managing database since 6.5, since SQL Server 6.5 up to Azure SQL. So I've done all of the versions of SQL Server. If you have any questions, just reach out to me. So yeah, so enough about me. We're here to talk about always encrypted. So what's always encrypted? Always encrypted was introduced at around SQL Server 2016. At first, it was an enterprise feature, but then when they came out with SP1, it became available for all edition. So it always encrypted is encryption in flight and at rest. What does it mean? Remember, we talked about TDE, wherein your data is encrypted at rest because it's stored when it is encrypted at the storage level. For always encrypted, the data is encrypted when in the storage and also while being transmitted between your client and your SQL Server. So the encryption and decryption happens on the client side, not on the SQL Server engine. This is trying to address a very common issue. Ever since, even before Always Encrypted came out, one of the concerns is when you have a database administrator or database operator, they usually have complete access to your data. Even for example, if you have cell level encryption, your database admin can see the data in plain text. He has a way to see the data. So it's a privacy concern, for example, especially right now during the cloud era, wherein your database is hosted on an outside provider. So there are different database operators working on your database that are essentially not part of your company. So it is a big privacy concern, right? So always encrypted allows you to separate the role between the database administrators and database operators, and to those users who are supposed to see the data. So your data is only visible to your application through your application. It won't be the plain text information won't be available for your high privileged users like your database administrators. So the DBA cannot access your data. And always encrypted, we'll gonna talk about how always encrypted implements this scenario. So in terms of encryption mechanism for always encrypted, you have two types of keys, column master key and column encryption key. Your column master key is resides outside your database. It's on a separate location. So only those that requires permission for the master key has access to the master key. It's not stored on your database server or in your database engine. Column encryption key, on the other hand, is stored on your database engine. It is used to encrypt your data. Column master key encrypts your column encryption key, and column encryption key encrypts your data. There's two types of encryption for always encrypted. The first one is randomized, wherein the ciphertext for your data is always different, regardless if you're encrypting the same information. For example, you're encrypting hello world. For randomized, the ciphertext for hello world will always be different. For deterministic, the ciphertext for your plain text information will be the same. It's still encrypted, but the ciphertext for the same words or the same information is the same. The different that's the main difference between the two. The advantage on that is for deterministic, you can create indexes on the column because the values are, as the word it says, they can determine the value for it. So you can do simple equality operations on deterministic, but for randomized you can't. And in terms of algorithm, there's only one right now. That's the algorithm that we use for always encrypted. And then let's take a look at how always encrypted works. So first you have your database, and you have your data inside your database. So like I said earlier, when you want to use always encrypted, what you need is you need to have a column master key. Your column master key is not saved within your server. It is saved in your key store on a separate environment than your database engine. You can use a Windows Certificate Store, an Azure Key Vault, or if you want to use a third-party provider, you can use a key storage provider. But your key storage provider needs to have the same. It needs to be able to talk to the client drivers for always encrypted. So you have your column master key, and then you create your column encryption key. Your column encryption key resides on your database. This will be used to encrypt your data. You use the column master key to encrypt your column encryption key, and then in turn, the column encryption key encrypts your data. So that's how the two keys work and how your data is encrypted. If you look at it from the application perspective, you have your application here. The encryption happens on the client driver. Like we said, the encryption for always encrypted happens on your application side. So you have it needs a specific client driver that has the always encrypted capability. So, for example, you're sending data to your SQL Server. Your data on the application side is plain text. Your client driver contacts your key vault, checks on the master key, use it to decrypt and the encryption key from the database, put it on the client driver, and then encrypt this plain text data. After it encrypts the data, it will send the data to your SQL Server. So your SQL Server engine will only see the ciphertext. It will never see the plain text data because it's already encrypted before it is sent to your SQL Server. That's why it's always encrypted. So it's encrypted in flight and at rest. So the data goes through the network already encrypted, and then it's stored on your database encrypted. So like this. So what you see on your database is the encrypted value. There's no way for you to see the unencrypted value. If you want to view the unencrypted value, for example, you query your database, what happens is the SQL Server sends the data, the encrypted data, the ciphertext to your application. The client driver on your application side is the one that will decrypt the ciphertext and then display the data for your application in plain text. So all the decryption and encryption happens on the client driver. It's not happening on your SQL Server. That's why it's separated. So only the users that require access to your plain text data can view your data, not on the engine. The downside on that is you cannot do any computation or any comparison for the data on the SQL Server side because it doesn't have any capability to decrypt and encrypt your data. So if you are going to manipulate your data, for example, you need to do some computations, you need to do some joins or you need to manipulate your data. You need to get the data out first from the SQL Server, get it to your application, and do your computation on the application layer, not on the database. So let's just compare quickly the three items that we have already discussed. So TDE, the encryption happens on the storage level. For cell encryption and always for cell encryption, the cell level encryption, the encryption happens on your database engine. For always encrypted, it's the encryption and decryption happens on your client side. So is it encrypted at rest? For all of them, it's yes. Is it encrypted in transit? For TDE and cell level, no, because you decrypt, even for cell level, you decrypt on the database engine. For TDE, once your data is loaded to the buffer pool, it's already decrypted. It's only encrypted on the storage level. So it's not going to be encrypted in transit when you query your data. The only way to encrypt in transit for TDE and cell level encryption is to use SSL together with it. Role separation. So for TDE and cell level encryption, there's no real role separation. Your database administrator will always have the ability and the permission to decrypt your data. For always encrypted, there is a role separation because your master key is not stored on your database. So if you don't want your database admin to decrypt your data, if you don't want him to have access to your plain text data, don't give him the permission to access your master key. Schema changes required. For TTE, there's no schema changes required. For cell level encryption, there is schema changes. You need to change the column itself. And then for always encrypted, well, on the documentation, it's going to say there's no changes required. Well, but I'm going to show you later on why I put an asterisk on that. Does it require any specific client drivers? For TD, it's not. There's no specific requirement. From the name itself, it's transparent to your user. So there's no need. There's no changes on the application side. For cell level encryption, there's no specific driver for it because the decryption and encryption happen on your database engine. For always encrypted, there is a specific requirement for client drivers. There are a number of drivers available out there that allows always encrypted. For example, for .NET Framework 4.5, I think, allows always encrypted, as well as there are some ODBC that allows AE. So if you're gonna use AE, you need that on your client side, on your application. So enough talk, let's take a look at how it works and how we can set up AE. There's a question. There's a question on the chat. Does this also protect the data when in backup and when restoring the data to another server? How is how is this related to TDE? So as I mentioned earlier, your data on the data is stored encrypted. So it's the ciphertext that is stored on your database. There's no way for anyone to unencrypt that without the client, one, without the client driver, and two, without access to the master key. So does it protect your data when in backup? Yes, because when you backup, the contents of the backup is still the encrypted text. It's not the plain text. So there's no way for them to, they can restore that, yes, but there's no way for them to unencrypt the data without the master key. So let's take a look. I have, oh, before I go there, someone asked last week about how do you do TDE on Azure SQL. The reason why I didn't go through with it when we did TDE is it's very easy to enable TDE for SQL database because it's only a toggle here. You just need to toggle TDE here and it's gonna create the certificate for you. It manages the certificate for you. You don't need to do anything. You just need to toggle this. That's why we didn't do a demo because it's just a switch. You can go to the portal and then turn it on. All right, so let's take a look here. Let me just restore your database because I don't wanna. All right, let me change my connection. All right, so we have a database here named TDE demo, TDE demo 1. I have a table named employees. If you were with us on episode 1, this is the same table that we had. So we have a column here, NRIC, which is the sort of like the identification number for Singapore. So take a look here, Nancy and Andrew has the same NRIC. We're just gonna use it for demo. So first, let's create a new table. Let's create a new table for one for random and one for deterministic. You can have multiple columns with different encryption type for always encrypted. I just want to separate them on two tables so that we can take a look better. So it will have the same information as employees. All right, so it's the same table. Let's take a look at how the table looks. Because remember, by right, there's no schema changes for always encrypted. So we go here, for example, deterministic. Let's take a look at the table. So this is NRIC. This is the column that we want to encrypt. So currently it's nvarchar 9. Our database, let's see what's the collation for my database. It's the default collation, I think. So it's SQL Latin 1 General CP1 CIAS. So that means that's also the collation of the tables and the column. All right. So that's the table. You can enable always encrypted through SMS. It allows you to do that. There's a section here. If you go to security, always encrypted keys, here's your column master keys for this database, and these are the column encryption keys for your for this database. So right now there's no column master key here. You can see here the types of key store that are currently allowed. So we're Windows Certificate Store current user. What this means is it's when it creates the certificate, it will save it on the registry key for that current user. For example, right now I'm logging as my user POB. So the certificate key will be on that profile, on the HK, on the registry, HKey user. What that means is no matter it's unique for my user. If, for example, there's another user who's going to use this PC, you won't be able to use that certificate. There's another certificate store called local machine if you want to store it on the registry key for the HK machine. So that means any user on this server will have access on that certificate, so he can read that certificate. Then Azure Key Vault, you just need to log into your Azure subscription. So I have here Azure, I have a key vault here. So if you haven't created one, you need to create first before you create a key here. And then you can generate a new key. These will be stored on your Azure Key Vault. And then the last option for a key store is a key storage provider, CNG. So that's a third party one. But today I'm not gonna do it on SMS. I'm gonna show you how to do it on PowerShell for two reasons. Usually when you watch demos for AE, what they have is or what they usually use to demo is a simple .NET application that you can enter your data. So in this demo, we're gonna do it on PowerShell because I wanna show you some information, some details that you won't be able to see if you do it if you do a whole application for it. Okay, let's first create. Let me clear this up. So let's first create the keys. If you look here, so I'm just gonna create a new self-signed certificate on my local key store. So it's current user, so it's my user. You need to have the SQL Server module if you're doing this, and then the server name and the database name. So I'm gonna create a column master key named TDE demo1 CMK, and then later after that we're gonna create a column encryption key named TDE demo1 CEK. So that's what the script is trying to do. Actually, if you're gonna do this in your environment, I advise doing it on PowerShell instead of SMS because it's a lot more. You have more control, and it's easier because here you need to pass the certificate to your when you create the column encryption key. You need to pass you see here, same case settings. I'm passing the thumbprint of my certificate. So let's do this. TDE demo1, TDE demo key. So let's go back to the Management Studio. Now we have here the master key and the encryption key TDE demo1 CEK. So the next step we're gonna do is we want to encrypt the column. So earlier I said we want to encrypt the NRIC. So let's go back here. To do that, you need to use the sets SQL column encryption, and this is one of the reasons why I'm doing it on PowerShell instead of SSMS. If you have an existing data, you cannot do in-place encryption for always encrypted. If you're just using always encrypted, because it needs to remigrate your data out of the table and then migrate it back into the table. So it needs to pull it out to the client and then put it back in. So for PowerShell, it's using the client drivers for .NET Framework, so it can do that. So here, I'm importing the module, the server name, the database name, and then here is where I'm trying to encrypt. See here, DBO emp random NRIC, which is the column, and then emp deterministic NRIC. So those two columns you're gonna encrypt on those two different databases. You can have multiple encryption keys. You can have on a database, and you can have multiple master keys that encrypts those encryption key. It doesn't need to be one-to-one. But for simplicity, we're just going to use one. So here it's going to encrypt the column. You see here, it's preparing the data, it's migrating the data out using the client driver and then migrating it back in. And trying to encrypt the data. Let's see. All right, it's done. If we go back now, and we select, remember we select emp random and deterministic earlier on. If we select the data now the data is already encrypted. I cannot see the value anymore. And then take a look here. The second table is deterministic. Let's take a look here. Remember, Nancy and Andrew has the same NRIC. Look here, the value for these two, since we're using deterministic, is the same. Let me see if I can zoom in for you. There you go. The value for the two is the same, exactly the same, because we're using deterministic for that table. And then let's take a look at the table. This is one of the reasons why I put an asterisk on the no schema changes. By right, there is no schema changes because you don't need to do anything. But if you go to the table itself, you can see here for always encrypted, the collation for the column changes. It needs to be in one of the binary to column encryption collation. So this is how you encrypt. This is the command if you want to encrypt using T-SQL. And here, like I said earlier, this is the algorithm being used by always encrypted. So you just change here if you want to change it to randomized or deterministic. So you can see there is a change in the table itself, but it's transparent to you. So that's the stable structure. And but how can I read it? Right? There's no way for me to read the data. But since this will only work because my master key is on the same server. By right, if you want to read the information, you need access to the encryption key. So I'm on the same machine, so I can do that. But you need to enable always encrypted connection. Later on, we're going to talk about enclave attestation URL. But for always encrypted, you just need to enable this. For older versions of SSMS, we just need to column encryption enabled. You need to add the parameter here. So enable always encrypted, then we can connect. Once we do that, we can view the data itself. So it's still encrypted. It still is stored encrypted on the server. But since my client connection is using encryption column enabled, so I'm using the drivers, the client drivers to decrypt my data. Will this work with Power BI? Yeah, Power BI uses .NET Framework 4.5, so it will be able to. Yeah, so how do we insert data, right? For always encrypted, let's see, let's try here. My connection is already using always encrypted on, right? But I won't be able to insert data. For always encrypted, hang on. I forgot to close my door. Sorry about that. Yeah, so you cannot insert data to the table. through SMS, because for always encrypted, you can only insert your data. It needs your it needs the information to be strongly typed. That means you need to specify the variable type of the column, because it doesn't know. So what you usually do is you create a stored procedure to do your insert, because stored procedure are parameterized, right? Either that or you enable parameterization on your server. So we will create this SP. It's nothing special. It's straight away insert. So we just specify the parameter, but okay, let's just take a look at here. So that's the SP we already created, but I'm using SMS. If I execute that, it's still gonna give me the error, because, like I said, it needs to be strongly typed. Even if you specify the nvarchar, for example here, we already declaring it as a variable. You cannot manipulate your data using SMS because it's a backend tool. The only way for you to insert or modify your data is through the application. So still the same error. Let's go to Power BI, to PowerShell. Remember I said this one is using the client drivers. So it's the same. This is my application. If you see here, let me see if let me do this. Let's take a look at the data. Oh, sorry. Let me do that. Wait a minute. Let's do this first. So if I do this, we can read the data. You can see the NRIC because we're using column encryption setting equal to enabled. If we change that, if your connection doesn't specify the column encryption enabled, you won't be able to view the data. So you see here, what you will see is the encrypted format. You won't be able to see the plain text. So it's gonna be the same thing. Even I'm already using a client driver here, I won't be able to insert values like this. Just a plain ad hoc statement with a insert value, insert into command. If I do that, it will still give us the same error that we receive at in SMS, even if we use the SP that we created. See here with the SPM deterministic. Even if that's the one that we use, we won't be able to insert. I know for the developers out there, this is not the right way of executing a command, but it's the same thing. It's just gonna pass the row inserted successfully if it's correct. So it's still the same thing. It will give you error. So for always encrypted, the data needs to be strongly typed. So if you look at here, it's gonna be the same if you do this on C# or any other programming language. You need to specify the variable. You see here, I'm building a SQL command to as a new SQL command. So I'm adding the parameters here. For the other parameters, I don't need to specify anything, just the name and the parameter value. But for the encrypted column, you need to strongly type your column, the data type. So I need to specify what data type it is, and I need to specify the length, because the database engine doesn't know the definition, right? Because it's encrypted. So what happens is it needs that information so that the client driver can rewrite the query to the correct command that it will pass to the SQL engine. So here, So once I hit F5, this section will be able to insert the information. I made a mistake earlier on. I hit F5. That's why you see one there. But if we do it again, there's gonna be two insert. So if we do this, let's see. Oh, we didn't change this. All right, let's try that again. So let's take a look at the other table. Oh, wait. Sorry. Again. All right, there. I forgot to uncomment the line. So you see here, it inserted. We now have 2DBA Balistoy EO because I already clicked it twice. If I hit it again, it should be able to insert another line. And now you have 3. So the only way to manipulate your data when you have AE is through your application. You won't be able to manipulate it through backend. That's the advantage of using AE. There is no way for you to change your data from the database itself. So let's go back to the slides. There are just some questions. Let me just address them. From Okim, any performance consideration if you use both TDE and always encrypted? I don't see the reason why you will need both. Usually what you do is you either use TDE or you use AE. It's already an overkill if you use TDE and AE. But in terms of performance impact, as we discussed last episode, right? The performance impact for TDE is very minimal. The last time they did the benchmarking is the change in performance of a TDE database to a non-TDE database is just around 3%, which is very minimal. So it doesn't really, it's negligible. But there, I don't see a reason why you will need to enable both, since your data will already be encrypted. When you use AE, your important data is already encrypted. So what's the need for TDE? But good question. Something to try. How can I restrict the user to add the connection parameter column encryption setting enabled? Because the encryption data become decrypted when I log in and add this parameter. Now remember, it's not just that. You need to have access to the master key for you to be able to decrypt. So if you want to restrict your user from being able to decrypt your data, don't give them access to your master key. Then even if they enable the connection parameter to column encryption setting to enable, they won't be able to read the data. And yes, the last question is, will this work with Power BI? As I mentioned earlier, Power BI uses .NET Framework 4.1, so 4.5, so it should be able to. All right, so going back. So in summary, where am I? Let me just go back to the slide. All right, so in summary, always encrypts your data in flight and at rest. Your decryption always happens on your client side, so there is a separation of roles. Your unencrypted data can only be viewed by your users from the application. Your database operators and database administrator doesn't have access to it. They cannot do that on the server itself. Yeah, so it can encrypt specific column just like cell level encryption. Column master key is stored outside the database. So if you want to restrict your user from being able to decrypt your information, don't give them access to your master key. Separation of roles, like I said, your DBA doesn't have access to your data. And you have two types of encryption, deterministic and randomized. Deterministic allows, oh, did I show you guys that? Let me just go back. We can still take a look at that. We still have time. If you look here, the random, this is the one that we encrypt using random. You won't be able to use group by. But here, deterministic, since the values are the same for the same values, it will be able to do a group by. For deterministic simple equality operation, it can do it. It can do simple equality operation. Random, you cannot do anything. Indexes, non-clustered indexes, you can also do that for deterministic, but not for random because it cannot. There's no point. All the data is different. So going back to our summary. So, but what if I want complex computation and operations for my encrypted data? So as we've shown, even group by, right? You cannot do group by for randomize. Any equality operation you cannot. Any comparison you cannot do. Any computation you cannot do. You have to pull the data out from the database to put it on your client and do your computation on the application layer, which is a very big disadvantage for AE because those computation the computation on the application layer is very limited. That's where so you see here, you need to bring your data out, bring it here to plain text before you can do any operation, any comparison, any grouping, any computation on your data. For example, even if it's an integer value or a decimal value, you need to convert it to plain text before you do computation. You won't be able to do it on the SQL Server, which is a very big disadvantage. That's where Secure Enclave comes in. Secure Enclave allows you to have a protected portion on the SQL Server memory on your server, on your database engine, wherein you can do your computation. So here, what it does is it allows you to it allows the client driver to check. It will check, do we have a secure enclave on this server? If it does, it can go ahead and decrypt the encryption key, pass it to the secure enclave. This is a secure channel. It's a black box. Any SQL Server processes doesn't have any information on what's happening on that portion of memory. It's a secure area on your memory that the unencrypted data can live. So even like I said, even the SQL Server processes, they won't be able to view what's happening on the secure enclave. Even if you use a debugger, the information won't be readable. So that's the secure enclave. Then once your plain text is on your enclave, you can do your computation. You can do in-place encryption and other rich computation that you require. When we say in-place encryption, remember earlier when we encrypt that table, because there's an existing information, it needs to remigrate the data. For always encrypted, you cannot, as I said earlier, you cannot do that using SMS because it's not pulling the data out because there's no client. So for secure enclave, you can do in-place encryption. You can manipulate your data within the secure enclave. And do, for example, if you want to re-encrypt your data using a new master key, you can do that on the server. There's no need to pull the data to the client. If you want to do rich computation, that's what Secure Enclave allows you to do. When you enable Secure Enclave, you can do equality operation on your randomized encrypted column. You can do more equality joins, and comparison on your deterministic encrypted column. So that's what secure enclave gives you. Now, for you to have a secure enclave, it depends on your hardware because it requires you to have a host guardian service. This is an this service is the one that does the attestation on that area of your memory. It's the one that verifies the certificate and say, yeah, it has the certificate. You can encrypt this portion of memory for me, and then that's the one uh, that handles that encryption. If we see here, remember earlier when we do the connection, if we have a secure enclave here, I don't have secure enclave because you need to configure HGS, and you need to have a data center edition of the server. It only runs on Windows SQL Server, Windows Server 2016 and 2019. HGS service only runs on that OS. So if we go here, you see here the enclave attestation URL. Once you enable HGS service, it will create a URL for you, like where that's the one that will verify your certificate, check your certificate, and then grants you that space in the memory for you to process your query. So that, like I said earlier, that portion of memory is not accessible to any other process on the server and from the SQL Server processes. It's uh, it's reserved for secure enclave for the encryption. Uh, and a few other items that you need to enable when you do secure enclave. Let's go back. So you need to specify this is a SP configure parameter, column encryption enclave type. You need to enable that. You need to enable trace on trace flag 127 if you want to do reach computation. And then when you create your master key, you need to specify enclave computation for it to be able to do secure enclave, for you to be able to use it for secure enclave. And with that, I right on time, 7:51. Do you have any questions? Let me just check. I wish I could demo secure enclave, but since I didn't know that I'm gonna do this session today. Today, I only found out that last week, so I wasn't able to configure a server that we can use it. And do we have any question? Aside from the one in the chat. Is it something that you think you can use in your production environment right now? No question. All right. It looks like there's no question. Oh, wait. So once the master key has been created, if they miss out on applying enclave, they have no chance. Yeah, you have to recreate your either create a new master key. Remember, I said earlier you can have multiple master key for one database. You can have multiple encryption key. You can even have multiple master key that it encrypts a certain encryption key. So if, for example, you want to use secure enclave, you need to create a new master key and then re-encrypt your encryption key. That's what that's one of the things that you can do with in-place encryption. You can rotate master key. By right, if you want to create a secure environment, right, you should have a process for rotating your keys. So you shouldn't be using one key for the entirety of the project. For example, since 2011, this is the same key that we've been using. No, it's not secure like that. You need to rotate your keys periodically. So yeah, you can re-encrypt your column using a new master key with secure enclave enabled for you to be able to reuse secure to for you to be able to use secure enclave, which is the same thing for example, you have existing environment right now that has always encrypted already enabled. So if you, for example, uh, you migrate to 2019, then you can enable secure enclave. Just create a new master key for it. All right. So if there's no more question, then thank you everyone. Uh, if you guys can drop an evaluation, you can use the link here, or you can scan the QR code or use the link. I can message the link on the chat. Let me just see. So we can rotate the key without decrypt and re-encrypt again. Invisible? No, not really invisible to the DBA. You need to when you rotate your key, right? You need to re-encrypt your column encryption key. So you need to, well, it depends on who's doing your rotation, but usually that's the DBA. So he'll know that you change your keys. All right, so I'll give you guys, well, if the PII, oh, there's more question. If the PII data in the DBA will temporarily have visibility? No, because the when rotating the key, no. When you rotate, remember earlier when we do the re-encrypt, it doesn't output the data, so there's no way for me to see it. Remember when we did this on the, where is it? When we did this part, it didn't output the, when you do encryption, it doesn't show you the data itself. It just shows you that you're migrating the data in and out, but you won't be able to see the actual data. So it won't be visible for your DBA. No, remember the encryption and decryption happen on your client key. There's a question on the chat. When you rotate your keys, what is the data in any time visible to your DBA unencrypted? No, because it needs to be unencrypted on your client side. So when we do the encryption on the column, there's no, the data itself you won't be able to see. If you go to the back end, if, for example, you're rotating the key, that means the data itself is encrypted already. So when you go to the table, it's still encrypted. And then when it's re-encrypted with the new key, the values will just be different, but you won't be able to see the plain text data. It's still going to be the new cipher data. So there is no gap wherein your database admin will be able to see the plain text data. You still need the application if you want to see the plain text, or if he has access to your old master key. And well, if you put it that way, right, then it's gonna be a trust issue if he's gonna use that to unencrypt your data. But yeah, the process itself, you won't be able to see the data. But what he does in between that, I won't be able to say, right? Right. All right. So yeah, we're just in time. I'm just gonna introduce. Yeah. So if you have time.
By the way, I like it. The Vitor Fava mentioned in this slide.
I forgot to change that.
That's fine.
Yeah. So Let me go. See, it's Fabiano. Right? Yeah, so let me just.
And actually, Pio, I don't have permission to present my screen.
Yeah,
Should I?
I'm. Let me just get you that.
Okay.
Yeah, so our next, let me just make him presenter first. All right, so our second session, we're gonna start right away with our second session. Our second session will be about SQL Server 2019 performance tuning improvements. Uh, our speaker is Fabiano Amorim. He's a Microsoft MVP for data platform from Brazil. He's I've worked with this guy. He used to be from my team, and whenever I have problems for query tuning issue, I throw it to him because he's very good at it. So I'm gonna let him introduce his session and introduce himself. It's all yours, Fabiano.
All right. Thank you, Pio. And thanks, everyone. And thank you for the invitation to the session. Like Pia mentioned, I do really love to do performance tuning work, and I've been doing it for a while. And let's talk about the SQL 19 performance tuning improvements. There are a lot of improvements in this version, but I actually want to cover a few of them. Let me share my screen. Share screen one. Should be this one. Okay, should be working. And then, so let's talk about the SQL 19. And again, thank you for the invitation for the session. If you guys are watching this session later on YouTube or the record of the session and have any questions, please feel free to send me an email with the questions and the slides and the scripts that I'm going to use. They should be available. I will also blog them in my blog. So just go to the blogfabiano.com after 1 hour from the session. I'm going to upload the files there. And yeah, I'm a SQL MVP from Brazil, so I'm really glad to be here and speaking with you guys. So just a bit about me. I do work with Pio at Ptian, and I'm a project engineer there, working with SQL most of the times with SQL Server and doing project work for our clients. And without any more introductions, and that's actually me when I started at Ptian. That picture is already very old. I'm not sure what happened in 5 years, because that only has 5 years, and I'm so different now. I guess I'm getting older really quick. And here's the agenda. I'm going a bit fast here because I do want to show all the things that I prepared for demos. So those are the things that I want to do demos, and actually there is one for this one as well. And I have to start by saying that on this version of SQL, I'm really impressed. And I wasn't impressed with a new version of SQL since SQL Server 2005. And that's where I actually looked at the version and I was saying, looking at the features and studying it, and it was like, wow, that's a really big deal. And I wasn't feeling the same with the other versions like 2012 or even 16. It was okay. I liked the features, they were cool, but now is the first time that I'm actually looking at one version and I'm really surprised and astonished because the performance tuning features are really, really great. And the thing that I like the most in this version is that the only thing you have to do to benefit from the feature, it's pretty much changed the compatibility level to 2019, and you're good to go. So I can see that many clients will be able to use those features really easily without requiring them to go back to the application and changing things there, or implementing a project to implement a feature or something like that. It's just really change the compatibility level, and you're good. All right, and then let's move forward with the first item I want to mention is this one. It's the support of the persisted memory drives. So Intel is pretty much the lead of the feature in the market now. So this is pretty much a disk, an in-memory disk that you can use in SQL Server, and then it's a memory disk, but when you put it in the memory slot, and the Windows will recognize it as a disk, and then you can put your database there, or your log file, or something, anything you want in the data in this drive, like TempDB, for instance. And the cool thing about it is not only that the performance is awesome because of the memory speed, right? Memory access speed, in both for reads and for writes. But the thing that I really like is that the SQL Server actually is, before I answer this question, the SQL Server is actually now recognizing that you were actually using a driver that it's persisted memory driver, and then it will behave differently because of it. So there are some things that a SQL usually do that it doesn't really make sense to keep doing it for this specific technology, and I will talk more about it in the next slide. So when I first saw these drives, and I was playing with it, and I was reading articles about it, I was thinking that, all right, so now that you can pretty much read at the speed of a memory and you can actually put your database there, does it mean that the performance tuning is something that we don't have to do anymore? So does it mean that performance tuning is dead? So all the work we were doing to avoid a table scan, for instance, do we really care about not doing a table scan anymore if we can do a 20 gig per second scan? Really, so if the table is 5 gig, it's going to take 0 seconds to read the 5 gig from memory. So I was thinking about it, and I think things are changing, and we will get there where in the point where the driver and the hardware, it's so powerful that performance tuning might not be that necessary. But I still think there are some nasty queries, and developers will continue to write queries that are really, really bad. For instance, this is a in clause, you see, and it's a parameterized query. And here's another sample of things that I do love that developers actually do. Here is a replace in another replace in another replace in another replace. And it doesn't really, and my point here is it doesn't matter the performance of your hardware. If users and developers continue to write queries like this, it doesn't matter the driver you're using, the hardware you have, the performance will continue to be bad, because this is really not a disk resource intensive query. This would require a lot of CPU, so we would still have the CPU problem for those queries, and they would still be very slow. It doesn't matter really you're using a persistent memory. So I do think that we still have things to improve and to optimize. Again, this is you see the in clause, it starts here at the row 47, the query, and look at where we are. So this is a huge query. This was actually 8 megabytes query. So that's a 8 megabytes query text sent to the SQL Server. That's a huge query. So performance will still be really bad on those queries. And then let me open a couple of execution plans just for you to have an idea what I'm talking about. Let me try to open this one. Let's see. You see, it takes a while just to open the execution plan. Let me see if it is opening. Where are you? Yeah, let me try from here. Open, come on. There we go. So this is one execution plan. You see I'm scrolling to the right here. And there we go. Look at the scroll bar here at the right. This is huge. Let me zoom to fit. Zoom to fit. There we go. You see, look at this. This is crazy. Let me open another one. So you see, it really doesn't matter that SQL 19 is awesome. You see, you can't have a good performance with things like that. You just can't. So I still think we have a lot of things to optimize out there. All right, let me come back here. And then just to leave you a link, because this one I do not have a disk, a persistent memory disk to play with it with. And so we have to go to the internet and see articles about it. And just to leave one, that this is the new IOPS record that Microsoft had with the Intel Optane disks. So they got, and this is huge, guys, 13 million IOPS per second. It's really IO operations per second is really huge. Just for you to see it, here's the throughput, 535 gigs per second. This is really huge. All right. And then again, when I was looking at the feature, I was considering that so this is a memory disk, right? But what SQL Server actually do when it is reading something from the data file for the MDF file, and it tries to read it from memory. If it is not there in the buffer pool, it is going to trigger the physical I/O operation and then read it from the disk and then put it in the buffer pool and then read it from the buffer pool. So I was thinking, if we consider that the disk it's actually a memory, what SQL Server was going to do was it was read from memory, put it in the DRAM memory, and then read it from the memory again. You see, it sounds like there is an extra step that is really not necessary here. And then that's where I told and mentioned that SQL is actually adjusting the engine to use those drivers. And then they are actually understanding that the driver you're using, it's a persistent memory. And then it's skipping the step of saving the information into the buffer pool, the regular buffer pool. And then it is just triggering the copy operation from the memory. So this is really cool. And this is actually available since SQL 17, the hybrid buffer pool. All right. There are still some things that I think they would have to adjust. That I was playing with it, and just to play with it, since I do not have a persistent memory drive, what I did was I kind of used I emulated a persistent memory drive, and then you can only do it with Linux. So there are no emulators for Windows. So what you could do is pretty much take part of your regular memory and present it to Linux as it was a persistent memory drive. So just a couple of links for you to be able to do it and play with it. The emulator is not that good, so when I played with it and I tried, I didn't really like the tests. I was expecting the much better performance, but I wasn't really able to see the real benefit of the feature. But again, I spoke with Microsoft about it, and they blamed the emulator. So if you really want to see the performance of it, you have to get in your hands one of those drives. All right, and now let's go to the cool features that I'm actually going to show them. So since 2017, there are these new set of features that Microsoft it's calling the query processing, intelligent query processing features. And it's pretty much the intelligent query processor that there are features that the query optimizer it's actually getting smarter, and then it's understanding from its mistakes and then behaving differently to avoid something that he understood was not really well. And then the first feature that I want to show here is the row memory grant feedback. That this feature actually exists on 17, but it only works for the batch mode operations. And now in the SQL 19, it works for both row mode and batch mode operations. So it doesn't matter if you do or do not have a column star index in the tables. So let me show how cool this is. So I have a script here. I'm still using the Northwind database as a test. So I'm going to create a new table called products big here. And then I'm setting the compatibility level to SQL 17, okay? So I do not want to have the feature, so I'm disabling it to show you the problem first and then how the feature works. And the feature, it's really straightforward. If you have a query that for some reason it's spilling data to TempDB, then the query optimizer will identify that the feature it's actually using the TempDB to process something, and then in the next execution of your query, the query optimizer will try to ask for more memory. So that's a memory grant feedback. So just to show you here, I have a query selecting products big and ordering by call test. And if we look at the execution plan here, it is going to read all the rows from 1 to 756, and then it's going to return all the rows to the sort operator, and then the sort will actually use memory because it has to keep the rows that it's receiving in memory, and then process the sort operation in memory, and then return the rows to the select operator. And the problem with this is that sometimes if the memory the SQL Server reserved to process this query is not enough, then you see, for instance, if I ask for just one more row, then you see that in the actual execution plan, now we have a warning here in the sort, and the warning is saying, hey, the operator used TempDB to spill data during execution. And that means that at the execution time, the query wrote a lot of pages into the TempDB, actually 757 pages to the TempDB, and then the memory grant it has was 6 megabytes. And then we can actually see the memory grant here as well. So select properties, and then we have the memory grant info here. So you see that the memory grant it acquired, it was granted, was 6 megabytes, and it wasn't enough. And the way it works is just like this. Before starts the execute the query, SQL Server will estimate how much memory it needs to process the query. And then if the memory that it estimated is not enough, then SQL will actually used MDB to process the operation. And the performance with one case and another one, it's really, really different. So just for you to have an idea, because I ran the query here, see, I'm actually flushing in the buffer pool, and then I'm clearing the plan cache. And then if I run the query, you see that the performance is really fast, right? It's 0 seconds. But actually, if I compare to the one that it's not using TempDB, the performance is really, really different. And to compare this, let me open the SQL Query Stress here. And then I have configuration here. So I'm going to run this query at the Northwind database. I will open 20 threads and run 5 iterations on each thread. So I'm kind of stressing the query to see the performance. And if I run this one that actually goes to the TempDB, look at the performance here. And while it's running, let me show you something, the resource monitor here. Let's see if I can catch it in time. Yeah, I do. So you see it's still running, and I'm writing here the TempDB file. So you see I'm writing 41 megabytes and reading 38 megabytes per second. And the response time, it's about the latency, it's about 35 milliseconds. So what's going on here is that while the query is running, and while you have many users running the query, I'm using TempDB a lot, right? And Pio, if you have questions, I'm not sure if you're moderating the chat. If you have questions and you want to stop me, feel free to do it, okay?
Yeah. Well, I'm gonna pass it to you when a question comes in.
Awesome, thank you. All right, so you see that the TempDB is being used a lot. And then the query that was actually taking 0 seconds in the management studio, once you applied to the production environment and you had 20 users running the same query at the same time, the performance was, you see, a lot slower. So it took 34 seconds to run this query. And let's say this is a problem that you have in your environment, and I'm 100% sure that you do have queries spilling data to TempDB in your environment, and you can look at the default trace to make to check if you do have it. So what do you have to do to fix it once you migrate to SQL 19? Is just change the compatibility level. So I'm going to change it. Now I'm using the 19 version, and then I'm going to run exactly the same thing. And what it is going to do now is that SQL Server will understand that the first execution was actually wrong at the memory reserved to process the query, and then it is going to adjust the memory grant for next executions. So let's see how much time it's going to take now with the new compatibility level. All right, let's go. All right, so 8 seconds. Okay, that's good enough, but let's try again. And there we go, 0 seconds. So you see, this is the memory grant feedback feature working and adjusting the memory grant size of the query automatically. So just for you to see here, this is happening. So I'm going to clear the procedure, the plan cache, and then the first call of the query will have a plan that it's actually going to the TempDB. So if we look here, we have the memory grant of about 6 megabytes. And then if I run the same query again, look at what happens. Let's try again. All right, there we go. Sometimes you have to run 1, 2, 3 times until the memory grant feedback actually kicks in. And now you see I do not have the warning anymore here. And now the memory grant is actually 18 megabytes, and that's perfect. And if I run it again, because it's 18, but it's actually, let's see how much it used. These are max use. You see, it used only 6 and it got 18. Let's run the query again. There we go, 9 megabytes. So you see, even it works for both sides. If it asks for too low, then it is going to spill to TempDB. And then the next time it's going to ask for more memory. But if it asks for too much, it is going to adjust it to ask for a little bit less. So that's really perfect feature. So the only thing you have to do is just go and enable the compatibility level. All right, and it works since 17, but on 17, to be able to use the memory grain feedback, you have to have a column start index, but it only works with the batch mode operations. And now on 19, it works for both row mode and batch mode operations. And if you're wondering, and what is the batch mode operations? There it is, the batch mode over row star. And let's go to the demo right now. And this is a friend of mine that I like to call him Demo. Yes.
Yeah, we have a question on the chat. Warner is asking if the feedback does not persist beyond restart, right?
Oh, yeah. So the memory grain feedback relies on the query plan that is in cache. So you see that once I cleaned up the cache, the next execution will not use the memory grain feedback. So if I run this, it's not spilling to TempDB, but once you clean the cache, then you're back to the problem. But you still have the problem, but only for the first execution, because the second one, hopefully the memory grain feedback will kicks in again and fix and adjust the memory grant. So it relies on the query that it's in cache and not in the query store, for instance. It would be nice to have it looking at the query store plan, because then you would have it persisted there. But if you restart the server or clean up the cache for some reason, or have a memory pressure that for some reason removed the plan from the cache, then you have the problem again. All right. So that's the batch mode. Let me talk about batch mode here. Batch mode row over row star. So again, now I'm going to do two demos, two queries I'm going to run. The first one is it's using the wide world importers data warehouse database, setting the database compatibility level to 19. And then here's what I have. I have two queries that I'm going to run. The first one, I will run the query not allowing a batch mode. And then I'm going to run the second one, exactly the same query, allowing the batch mode. And then let's compare the performance of those queries. And what I want to show is that, again, it's a really cool feature. And the performance, we can look here at the execution plan query time stats. So the first execution took 167 milliseconds. And then if we look here, we could see, so I'm looking at the column star scan here. We can see here the batch mode, the execution mode, it's actually in using the row mode. And then in a few words, what this is doing is that for each row, it is reading from the column start index, it is returning the row to the next operator. And that's just the way it works by default. That's the row mode. So that's a row by row read. And then in this one, you see that it's using batch mode. What it actually does, it reads a few rows at the same time. So it reads a batch of rows. The exactly number of rows depends on the number of columns you have in the segment. So it usually goes from 16 to 900, up to 900 rows for each read. And then there are some other specifics that makes the batch mode rows read for many rows a lot faster, especially when it's running in parallel. But the cool thing is that because it is not reading row by row, and it is reading a batch of rows per time, then the performance it's a lot better. So you see that now this one only took 10 milliseconds. That's a huge difference. And the only thing that I changed is that one it's using the batch mode operation and the other one it's using the row mode operation. Again, the only thing you have to do is enable the compatibility level and you are done. All right, so SQL Server is still the one deciding whether to use batch mode or not. So it's still a cost-based optimizer decision to use it or not. So you can try to force it, but at the end, SQL will decide for you. The Cryptomizer will decide for you if he wants and if he thinks batch mode should be used or not. You can force-ish. But yeah, Cryptomizer will decide it for you. And it has many things it takes in consideration to decide whether to enable it or not. So the table size, for instance, the operators use it. And then just to give you one sample, I have here two tables, one with 131,071 rows, you see, and the other one with just one row more than the other table. So I have two tables, and if I try to read them, let me use Northwind here. So you see I have the query reading the table with one here, and another query reading just one more row. And both of them are allowing batch mode to be used. And if I run them, if we look here in the time stat, so the first one took 508 milliseconds, and the second one took same time. Let me run that again. That was too much. Okay, so the 53 milliseconds versus 10 milliseconds. Okay, and the difference that the first one did not use the batch mode, and the second one it's actually using the batch mode. So you see that the number of rows is something that Cryptomizer takes in consideration. So depending on the number of rows you're going to read, it might enable batch mode or not. And then you could actually try to override the batch mode heuristics here using this hint, and then even reading the table with less rows than the threshold, internal threshold, I could benefit or enable the batch mode, you see. So this is one thing that you could try. And then for more information about it, you could look at the this blog post for a friend of mine, the Russian guy. So this is a really cool blog, by the way. If you like performance tuning, you should read all his articles. All right, so this is the batch mode. Cool feature again. And then another one is a table variable deferred compilation. So table variables are a problem for a long, long time in SQL. And the problem with the table variables is that, again, creating a table here to use in the tests. All right. And then setting compatibility level of 17. And then the problem with a table variable, it's that, you know, the Cryptomizer doesn't know how many rows you actually have in the table variable because they do not have statistics. So every time you read the table for some reason, now here's what I'm doing. I'm reading customers, but I only want to return customers that actually are in the table tab 1. And so this is actually cool, right? You can use star here in the one column. Yeah, you can, but only if your table has only one column. So in that case, my table variable only have one column. So so you see, I'm inserting some rows here from the customer's big table, and then I'm trying to read only the rows that actually exists here in the table. And then if we look at the execution plan, this plan is not really good because you see here the SQL, it's reading the table and estimating that only one row would be returned from this, and then trying to seek the row in the customers table. And you see, it thinks that the rows that are actually going to match from the loop join, it's only one, but actually it returned 49,000 rows. And then it caused another problem that the memory reserved to process this distinct operation, because I'm selecting distinct in a query, it was not enough, and then it spilled data to TempDB. So there are all sorts of problems just because the number of rows estimated to be returned from the table variable, it's 1. And what changed in SQL 19 is that the query optimizer is deferring the compilation of the plan to after it reads the number of rows in the table variable. Once it knows how many rows it has there, then it is going to decide what to do with execution plan, which batch to follow, which plan to create. So for instance, let me do the same thing, but with the compatibility level of 19, exactly the same query. You see now that the plan is very different. We do not have spill to TempDB, and there is a hash match here before actually do the join. And if we look here, the estimated number of rows, it's perfect. So based on this cardinality, then it is going to decide what to do with the plan. All right, so this is just the way it works. So no more need to use temporary tables, Fabiano, right? Not so fast. There are still some cases where you should use temporary tables instead of table variables, and I think you should be using in almost all of the cases, almost. But here's one sample. I have heard some people saying, for instance, that it's okay for you to use temporary table variables if you're actually inserting just a few rows in it, and it is not really true. For instance, let me create a table here we're going to use for the test. Here's what I have. I have a table variable here, and I'm going to insert only one row, all right? And then I have a query that it's actually using the table variable. So I'm reading the orders big and joining that table variable. So that should return only the row that actually match, right? The order ID or the customer ID 1. And then look at the execution plan. And remember, I do have 19 enabled, SQL 19 compatibility level. So the deferred compilation, it's working. But now I only have one row, right? So it doesn't really matter that it was already estimating one row. But let me run it for you. And if we look at the plan here, so first of all, it took 2 seconds to run. And if we look at the plan, you see it estimated it was going to return one row, and it is right because it only exists one row. And then it is doing the plan and whatever, it's scanning the table. So, all right, it is scanning the table, running in parallel, nasty plan, taking 2 seconds to run. And what happens if I do exactly the same thing with a table, a temporary table that do have statistic? Then look at the plan and the performance. There we go, 0 seconds, and completely different plan. Now it understood that it's going to return only one row from here, and then it thinks it's okay to do a key lookup. So you see, there are still cases where you need to use temporary tables instead of table variables. So I do recommend you use temporary tables in most of the cases. All right. Okay, so next one is the scalar UDF inlining. Let's go to the demo again. All right, so again, creating a couple of tables we are going to use in the test. And then here's the feature. Scalar functions, so also known as functions that return one specific data type, something, return a varchar or int or something. Scalar functions are really, really bad for performance, and that's a problem for a while as well, because they run row by row, right? They are executed for each row in your query. And this feature of automatic inline scalar functions, it's really, really cool as well. So in the SQL modules table, system table, there is a column here. See, it's called is inlineable. And for the function that I created, it's marked to 1. So yes. So I'm doing a really dummy thing here based on something that I received. I'm going to return only the right up to something in 2 characters. In this case, I'm going to use 2. So for instance, let me call the function here so for you to see what this is doing. So let's say I'm trying to read based on Fabiano, only the last 2 characters. Not working. Varchar 2. What did I do? Oh, because the result is int. So sorry, my bad. It's 3, 4, 5, 1, 2, 0, 5. There we go. So it's returning only the last 2 characters. So this is what the function is doing. And here is what I have to show the problem of this. So I'm disabling the inline function here using this hint. And here's a query I have. I'm reading the orders big table and the column value. So let me read the table here just for you to see what's in it. So I have a column value here, you see. I'm actually summarizing all the decimals here, you see. So the last 2 characters. So that's what I'm doing. The table has 1 million rows. And then question, how many times do you think the function will be executed? So if the table has 1 million rows, how many times would you expect the function to be executed? 1 million, right? Not so fast. And the problem here is, let me run it. You see that it's taking some time to run, and it is taking some time because of the function. And the problem here is not only that the function is bad, but the function is actually bad and you're actually running it twice per each row. So you see I'm reading, it's actually 2 million rows, okay, in the table. So I'm reading the rows here, and then I'm aggregating because I have the sum. And if we look at a string aggregate here, and then if we go to the defined values, I'm expanded here. You see that we have 2 expressions being calculated here. So one is this expression, and the other one is this one. And one is actually doing the sum, and here's the function being used. And another one is count big, and here's the function being used. So for each row, the function is going to be called twice because the string aggregate is actually returning 2 things. Even though you're not asking for the count big, the string aggregate actually requires it to the sum. And the reason it requires it is that because if you do not return any rows, then it has to return no, because if you sum something from a table and the table is empty, then you're not going to receive an empty result set. You're going to receive no result set. In this case, I would probably have the 0 result set. So, and this is the problem. 1, the function is really bad for performance, and 2, the function is being executed twice. And if we look at here at the query time stats, we actually have new information here in the query plan. 16, I think, SQL 16, we have the UDF CPU time here. So you see the query took 8 seconds to run, but only executing the function SQL took 7.5 seconds. This is really, really, really bad. And one of the things that everyone is well known that you could do to optimize a function, a scalar function, is to convert it into an inline function. And an inline function is the function that returns a select statement. So instead of returning the int value, I'm actually now returning the select something. Okay, and then instead of calling the function here, I have actually to cross apply with it. So that's the inline function. And then the performance here, it's really, really good. You see, 0 seconds instead of 8 seconds. That's perfect, right? But what's the problem is that you have to rewrite your query, you have to use cross apply, you have to create an inline version of it. And then on 19, the feature that we are talking about, the automatic inline function, it's inline scalar function, it's that SQL do it automatically for you. So if I run the same query without the disable scalar UDF inline, you see that here's the performance, 0 seconds, right? That's perfect. So what I would expect is that all those queries that you have inline functions that are able to be inlineable, then those queries will be a lot faster, okay? All right, let me move forward here, otherwise I will not be able to show all the things. So the next demo is the accelerated database recovery, and that GIF, I really like it. Here is the representation when you remember that you were out for lunch and you remembered that you let the transaction opened. You forgot to commit the transaction or to roll back it. The problem with this is that, you know, if you start a transaction and start changing a lot of things, all those things will be written to the transaction log, and then the transaction log, that information will not be cleaned up if the transaction is opened, right? And here's the problem we have that is very common. The rollback process of a transaction takes forever. And this is one of my favorite features in the 19. It's the accelerated database recovery. And here's how it works. The idea is to make the rollback process a lot faster than usual. So here's what I have. So let me close all those sessions. All right. Not sure why it's taking. Let me see. I probably blocked by something who is active. Yeah. Cool. Oh, it's probably SQL query stress. Let me close it. Okay. Let's see. Still blocked. Yeah. Let me kill this session. Who is blocking me? 60. Okay. Oh, that's me. All right, there we go. So I'm just making sure that accelerated database recovery is off in the database we are going to use for the test, and using Northwind. And I have here a table called the big table. Let me see if it's there. Yeah, it is. So it's a table with about 2 gig size in 2 million rows. And here's what I'm going to do. I'm going to run this delete has a developer with production access mode. All right. So I was supposed to actually run the delete statement selecting the where clause, but you know, I'm a developer and I'm connecting it to the production database. I'm going to run the delete statement. And oh my God, I forgot to select the where clause. But yeah, I'm only going to notice this, that I forgot to select the where clause after 13 seconds. And then now It's been already 20 seconds and now I forgot it. And then what I'm going to do is I'm going to hit cancel button, cancel. And then, it is going to cancel because that's an implicit transaction here. And then, but I'm trying to stop here and then it's not stopping. It says that it's canceling the query, but it's not canceling. Let me try to close this. Yes, let me close. Yes, I want to cancel it. Please. You see, I'm desperate. And then I'm going to check who is active to see if the query is still alive. And oh my God, the query is still alive. Let me kill it. Please, I want to cancel. Oh my God, the query is still alive. So the next step you are going to do our favorite thing. You're going to stop the engine, the service, because you're desperate and the query is still running and you do not want to delete all the rows. Stop in the service. Come on. Go ahead. All right.
Is this from True to Life experience?
Oh yeah, that who never did it, right? I've never done a delete in production. All right, so it's finally back. Let's see if so the query finally is finally dead, but let me refresh here and see what's going on now. And hopefully it's going to work. Let's see. I can also, in the meantime, select from databases. And then let's see the Northwind database here. Oh, you see the state for the Northwind database? It's in recovery. So, everyone did it once, at least once in production. It was desperate. And then, going back to the real life, you have this maintenance plan that you have to apply, the change in the application. And one of the things that you are going to do in the application change is that you are adding a new column in a huge table, and then the other table statement was taking 4 hours and did not finish yet. And then we're almost running out of the window you had to do the maintenance. And then, all right, you decided since it is taking 4 hours, it didn't finish yet, I'm going to stop it and I'm going to continue tomorrow in the next maintenance window. And once you try to stop it, it wasn't stopping, and you realize the query was still there and still running, and you try to kill the session, and then you restarted the service, and then your database came back in recovery mode. And that's just because the way it works, right, guys? It has to roll back the transaction that you were running. And usually the rollback process takes a lot of time. It should be done already. Let me refresh again. Yeah, it is. And then I could go to the SQL error log to see how much time it took. Yeah, there it is. So the recovery for rated recovery database that I mentioned is really cool. Let me enable it. All right, it's enabled. Let me use the Northwind. And what it actually does, it has some techniques and some things it do internally to make the recovery process a lot faster, almost instantaneously. It usually takes 0 seconds. So for instance, if I run the same query, what it does, it kind of relies on versioning, and then it creates small checkpoints in the log, transaction log. So let me leave it running for 20 seconds like we did before, and then I'm going to stop it. So 20 seconds and then stop, and done. We are done. You see, the recovery already happened. And if we look at the table, let's see here how many rows we have in the table. We should have 2 million rows, right? Let's wait for it to read the 2 million rows. And yeah, that's just the way it works. You see, we do have the 2 million rows here. So one thing that I noticed that the feature is really cool, but it kind of internally, you see, it kind of messed up the statistics. You see that the estimated number of rows is wrong here, and actually, if you go to the SP space used and check the number of rows in the table, look at there. You see that the number is changing. That's because there is a cleanup thread that it's actually adjusting the rows internally. And there we go. The cleanup already ran, and we are back into the 2 million rows. Just a quick thing about the internal. There is this behavior that while you're waiting for the cleanup process to run and to insert the rows back into the table, the estimations, the statistic, it's a bit wrong. But this is it. The feature is really, really good. And as you know, the version star will have to use some space. So you need more space in the file. It does not use the tempdb, all right? So it actually used a local primary file group space. And if you do not want it to use the space for the primary file, because you may not have space in the file, you could create a new a new file group and a new file in the file group, and then specify the version star file group for the persisted version star for the auxiliary database recovery. This is really cool, right? You could have your own temporary database for this this feature, this versioning.
Yeah, we got a couple of questions.
All right.
Yeah, so for 2019, for snapshot isolation, is it also gonna use it? Will it still use TempDB, or is this only for ADR?
Yeah, that's a good question, and I don't know the answer. I think it's still using TempDB, but I don't know. I would have to try to make sure. So the answer for this question is I think it is still using TempDB and only using the file group that I specified here for the auxiliary database recovery. But I don't know.
Is it enabled by default, ADR?
No, it is not enabled by default. It is enabled by default on Azure, I think.
Yeah,
so in a SQL, in the SQL database in Azure, it's enabled by default, but not on premise. So once you create a new database or recover a database from a backup into 19, you will have to enable it. It's off by default.
We have another question, but it's on the temp table information.
All right.
We have a question from Ray Delara. I got confused on table variable versus temporary table. What if I only have few rows and I decided to use a temp table? Won't it be faster to use table variable, especially if your temp table has an index that needs to be updated too, unlike on table variables?
So the answer is no. Internally, they are exactly the same, temporary tables and table variables. So there is not such thing as the table variables are in memory, unless you actually use the in-memory feature of 19 and then define that it's schema only. So internally, they both could go to tempdb and disk file. So so the answer is no. Even though if you have a few rows, usually, all right, it's not always, and that's why I mentioned the word usually when I talked about it. Usually the temporary table, because it has statistics, you will have better plans while reading or modifying the temporary table of the data. Okay. All right, and then I do have a couple of 3 other demos here, but I don't think we have time for it. So I will leave it for maybe the next version of this session. So just want to go really quick about it. So there's this lightweight query profiling. You could enable a scope database configuration. Let me show you the scope or the trace flag. So you see that you have now the scope configuration of last query plan stats. You can enable it to on, and once it is on, you could actually, let me enable it, and that should be really quick. So I'm running a query here, and then you have access to this new DMV here, is exact query plan stats, and I'm looking at the KPS star here, so all the columns. And if I look at the query plan here that it's in cache, here's what you have. Oh, actual number of rows for the query plan that it's in cache? Yes, so that's the cool feature. You have actually the last executed plan, the last actual execution plan in cache. So that's really cool. And then you have the SP estimated data compression savings also working for column store and column store archive. So we could use the column store, for instance, to compress big tables, including for tables with XML columns that are in varchar max or varchar max that are page and row native page and row compressions do not compress, and column store does. There are some limitations, but they usually do. And then you have the new weight type called a weight on sync statistics refresh. So you know when you when auto update statistic is triggered, and your query is there waiting for the auto update statistics to finish before it creates an execution plan, you're just there waiting for nothing. By default, up to 17. If you have a query that it's waiting for the auto update statistics to finish, and you look at the exec or waiting tasks, you will not see your query. So you really don't know what's going on with the query, why it's not running. And now they finally added wait for it. So if auto update is running, you see that the wait on sync statistic refresh is actually there. And other improvements, there's the TempDB memory system objects. There's the MDB page info to replace the DBCC page. There are many compatibility level hints. You could check the hints in the exact valid hints, use hints DMV. There's the approximate count distinct. Other features that might be in the project in the future. For instance, this one I really like is the result set caching. This feature actually already works for the SQL data warehouse, but we do not have it yet. Who knows in the future? TempDB to remote store, that would be nice as well. So spill TempDB into a different database. So kind of the TempDB with its own database. Snapshot in views. So some features that are we kind of see them in the product, but they're not there yet, not complete. Yeah, but are worth mentioning. So again, guys, if you're watching the record of the session and want to ask questions, please feel free to do it. And here's my email if you want to send email as well. So I already over 2 minutes of the time.
Yeah, that's fine.
This is it, Pio. Any other questions? Let's look at the chat here.
There's one more question about SQL query stress tool.
Okay. Mm-hmm.
Yeah, so she's asking where she can get it, and the pages are showing deceptive page, or it doesn't exist. I'm not sure which pages the
pages are showing. The pages are showing deceptive pages. I'm not sure if I understood the question on the pages, but Lena, the crew stress, you could just Google SQL crew stress. That's actually is a free tool you can download. So Adam Mechanic actually wrote it, but now he published, and it's in the code. It's public, so it's in the
Yeah, I think he put
GitHub
it. He
somewhere.
put it in GitHub. Yeah,
Yeah.
I sent her the link, but I think that's
Oh,
the
perfect.
old one. But yeah, I think he moved it to GitHub, so you should be able to find it there.
Yeah.
Oh, there you go.
Yeah, perfect. Yeah, thanks, Warner. And what else? Any other questions, guys?
Let me just quickly check again on the look. Yeah, looks like we answered all the questions.
I like it, the note of Warner that prepare your resume while it's all hung. Yeah. Once you restart the service, oh my God, you would start calling people and say, "Hey, my database is in recovery mode for 6 hours. I don't know what to do." Yeah.
Oh, but it's unfair to say that it's a developer who did it, because I've known a junior DBA who have done that. So.
All right. Yeah, I agree.
Gotcha.
Yeah. At least I think in SQL 2012, the only thing that actually get blocked is the table that is being restored, right? So you could actually access the database while it's in recovery mode, but the only thing that you can't access it is the table. But I think prior to 2012, the whole thing is blocked.
Yeah. So, yeah. Any other question, guys? Yeah, definitely. One was saying is the difference between a junior DBA and a senior DBA is the senior DBA already screwed up production at some point, at many
Yes.
points in the past.
That's true.
Yeah.
All right.
Yeah. So, guys, if I put the evaluation link at the chat, if you guys want to, if you have time, kindly evaluate Fabiano's session. I'm counting down. Any more questions? I think that's all. Thank you, Fabiano. Very nice session. That's all for tonight, guys. Like I mentioned earlier, we won't have any session next week because the Office 365 group will have their monthly meetup. We'll resume July 14. We already have a speaker lineup for you. Watch out for the posts for that. That's all. Thank you, everyone. Good night and good morning to you.
Thank you, everyone. Thank you. Yeah. Thank you,
Bye-bye.
Pio. Thank you. Yeah, bye-bye.
Thank you.
Take care.
Thank you, Pio. Boa noite. That's good night. Boa noite.
Yeah, to the bang.
All right. Bye. See you, man.
Bye-bye.
Thank you.